15, Sybase gives the ability to create multiple Temp DBs. This has historically been a bottleneck in an ASE server. And the reason for that is we end up single threading through something. If you have, 5,000 simultaneous users, concurrent users, and they're all trying to get into, say, Temp DB to create a table, what happens when everybody's trying to get to the same system table to say, let's create an object? You need to get into sysobjects, syscolumns, you name it. We have the ability to spread this out. This becomes a bottleneck for both physical I/O and other system resources. Looks like there's an unfinished sentence here in the presentation. I do sometimes talk too fast. Am I okay? Work is one of the few places I can talk as fast as I want to and nobody complains. Great down here in New York. One of the things that folks have used often is solid-state devices. In fact, I used to do some work for EMC. Used to bring me in, a hardware vendor, because what would happen is people would have these very high-volume systems. Temp DB would be a bottleneck, and what's the fastest solution to eliminating a disk as a bottleneck? Just to memory. So EMC would sell these multi-million-dollar solid-state devices to be used for Temp DB. It would work most of the time. But on occasions when it didn't, they would bring me in to explain why it wasn't working and why it should not turn their multi-million-dollar solid-state device back. So that became kind of interesting. With the advent of recent changes, recent enhancements, you have the ability to create multiple Temp DBs. So now we're multi-threading through this. We can put these all on separate devices and we have that available to us. These days, separate devices has become the exception rather than rule. Everybody buys these great big SANs and everything tends to go on the same SAN. Do they go on the same physical drive? Well, sometimes. When you go to buy a SAN, how big are the individual drives that are attached to the LUNs? This big, and for those of you on the phone, I'm holding my arms stretched out. They tend to be, half a terabyte, 400 gigabytes, and it's hard to justify getting 10 or 20 different half a terabyte drives when you really only have a couple hundred gigabytes of data. So what we'll really do is we'll get as many as we can talk our CIO into buying, strike these with a RAID 10 or some equivalent, but having the multiple Temp DBs still helps you because you get the multi-threading through the multi-sets of system tables, multiple sets of spin locks, multiple sets of you name it. Multiple Temp DBs, you can do this in a lot of different ways. Very flexible process. Most of the time, what I end up doing is creating an extra several Temp DBs, and by several, it depends on the scope of what's going on and how much Temp DB is being used, how many processes are on the box. There's a recommendation out there on the web to put one Temp DB out there per processor. If you have a 20-processor box, you probably don't need 20 Temp DBs, but I'll go with 4 or 5 or 6 of them depending on the utilization. And set these up for all the users to round robin. I will also make sure I set one up for the SA's use. Now, when I first started doing this, I set this up as a relatively small Temp DB for the SA's use. And that was great because what happens is if somebody managed to fill up all the Temp DBs, you can still go out there and do an SP hood and SP lock and have everything run. Anybody ever tried running things like update stats or an update index stats with a tiny Temp DB? End up with problems doing that. So we do want to make sure Temp DB here. It should be Temp DB. So you want to make sure you have a Temp DB for the SA's use, and it does have to be big enough that when you run your update index stats on some very large tables, you're not going to run out of space. The way we do this, and I'm not going to go through how to set up a Temp DB here, it's a little bit out of scope, but do look up SP_Temp DB, and you can find out how your current setup is with the SP Temp DB show option. Again, just a couple of Temp DBs is generally good enough. This has caused some dramatic positive performance benefits in a lot of different places. Now, today with the later versions of 15, you do not use Temp DB as much for things like group buys, aggregates. A lot of the things that we used to do in Temp DB are now happening in procedure cache or in other areas of memory. Flip side is, I'm in a shop just this past week where they have several hundred concurrent batch jobs going on that are all using Temp DB. They were single threading. Somebody told them just to use a single Temp DB because they're just using the same SAN anyway. We increased that, and it did give them a significant performance benefit just simply getting into and out of the Temp DB issues. Some notes: make sure that each of the Temp DBs you create is large enough to handle most of the work sets. Do set them up for round robin. Do get yourself the multiple entry points. Make sure that if you have a particular process that needs a huge Temp DB, that process can be bound to the particular Temp DB, so you don't need to make all of them enormous. Next topic, data cache. One of the things that I frequently see, which is kind of silly, is insufficient data cache allocated and an insufficiently set up data cache. Sometimes it's an over set up data cache. Here's some guidelines for this. First, you want to make sure that you have enough data cache that you're getting good, solid, high 90s hit rates. I was at a shop. Things that happens these days. How many people here are only Sybase? Yeah, very few folks are only Sybase. Most folks also have SQL Server. They also have Oracle. And a lot of the folks who are administering the Sybase systems now really picked it up as an add-on because they've been doing Oracle for years or SQL Server for years. And in fact, we have a lot of Sybase folks who are just beginning to pick this up because they acquired a company that's got these things. And they'll look at the cache hit rates, they'll look at a sysmon output, and they'll say, I'm getting a 92% cache hit rate. That's pretty good. Honestly, a good cache hit rate is in the much higher 90s. I like to see 99.6, 99.7, 99.8, 99.9. It's not that expensive these days, and you won't always hit it. If you've got 4 terabytes of data, you're not going to be able to get 100% cache hit rate. But if they're much lower than that, you probably find that a lot of the index structures that you're trying to traverse are performing a lot of physical I/O. You want to avoid that. So make sure you have sufficient data cache to be able to hit these relatively high cache rates. Next, in your cache hit rate, make sure you have a 2-page buffer pool. If you're running a 2K page, this is a 4K buffer pool. This is used for the log. Now, and this is not a relatively new thing. For several releases out there, you have the ability to create multiply sized buffer pools in memory. You can create a 1-page, a 2-page, a 4-page, or an 8-page buffer pool. The 1-page buffer pool is, based on a 2K page, that's a 2K buffer pool. That's used for random page reads. So if we're trying to traverse an index, we'll start at the top of the index and read down. We're just picking up a page at a time. If you're trying to do things like table scans or index scans where we have lots of pages, and if we're lucky, they're even contiguous, we'll use the 16K buffer pool for that. Sorry, the 16-page buffer pool, or the 8-page buffer pool, or 16K buffer pool. What that's going to do is allow us to read multiple chunks of data at a time. If I'm reading 8 pages at a time, that's one request rather than 1 page at a time. And you may not get 8 times faster results, but it will be significantly faster. Now, in between, we also have a 2-page and a 4-page. I've never seen anything faster with a 4-page buffer pool. I simply don't use it. However, the 2-page buffer pool is significantly faster for the log. If you're doing OLTP and you do not have a 2-page buffer pool, you're probably missing a bet. I still see this at a lot of shops. It does not have to be big. A 50 or 100 meg buffer pool is probably sufficient for most intents and purposes. What you need to be able to contain there is the concurrent transactions that are being processed. That doesn't fit. Any overflow will go to the 2K log, the 1-page pool, but it doesn't have to go there. So check the cache utilization in the SP sysmon output. If you want to know whether or not you could use more or less of the 2-page log, keep an eye on the wash marker and see if you've got dirty data pages getting washed past that wash marker. That's a good indication that you could use a bigger buffer pool. Pretty unusual. The 8-page buffer pool, again, I still see a lot of shops that just have the 2K 1-page buffer pools out there. This can have a major performance impact, positive performance impact on things like table scans, index scans. As a starting point, I'll pick 20 to 25% of the cache size, make that set up for the large block I/O, the 8-page I/O, and watch the sysmon output. That'll tell me if I am over or underutilizing that cache. It'll also tell me, if you take a look at that, it'll also tell you whether you have issues where you're bringing a lot of the pages in and simply not using them. Maybe it's misusing the 8-page cache. That might be an indicator that you need to update your statistics a little more often. We'll talk about that shortly. Still with cache partitions, back in the time. Still with cache, talking about cache partitioning. One of the things we've done in the past